Today we're going to start section 4.4, Greatest Common Factor. In previous lessons, we've learned how to list the factors of numbers. Often, numbers will have some of the same factors. The greatest number that is a factor of two or more numbers is called the greatest common factor. There are three methods we can use to find the greatest common factor, or GCF. First, we can list the factors. Second, we can use prime factorization by using factor trees. Third, we can use the ladder method that we learned in section 4.3. In example 1, we're going to list the factors. Recall that this is the method we learned in 4.1. If you need to review how to list factors, look back at your notes for 4.1. We're going to find the GCF of 12 and 20. I'm going to go ahead and list the factors of these two numbers, but I'm not going to show you how to do the actual listing, as this is something you should already know how to do. So the factors of 12 are 1, 2, 3, 4, 6, and 12. The factors of 20 are 1, 2, 4, 5, 10, and 20. I found those factors by using the chart that we learned to use in section 4.1. The common factors of 12 and 20 are 1, 2, and 4. And the greatest common factor of 12 and 20 is 4. In example 2, we will use prime factorization to find GCF. You can use any of the methods we learned in section 4.3 to find the prime factorization of these two numbers. Once again, we'll find the GCF of 12 and 20, but this time using a different method. The prime factorization of 12 is 2 times 2 times 3. You can find that by either using the factor tree or using the ladder method. The prime factorization for 20 is 2 times 2 times 5. Common prime factors of 12 and 20 are 2 and 2. The GCF is the product of these common prime factors, so we multiply 2 times 2 and we get 4. The GCF of 12 and 20 is 4. In example 3, we will use the ladder method to find the GCF. We learned the ladder method in section 4.3. To find the GCF of 12 and 20 using the ladder method, we'll write 12 and 20 on the first rung of our ladder, and recall that we look at our prime factors, such as 2, 3, 5, 7, and 11, and we try to decide, is 12 divisible by 2? Yes. But this time we also need to look at 20. Is 20 divisible by 2? Yes. So we can divide both of these numbers by 2. 12 divided by 2 is 6. 20 divided by 2 is 10. We repeat the process then. Is 6 divisible by 2? Yes. Is 10 divisible by 2? Yes, it is. So we divide both numbers by 2. 6 divided by 2 is 3, and 10 divided by 2 is 5. Once again, we'll look to see if these numbers are divisible by the same prime number. If I look at 3 and 5, both of them are prime numbers, so I know they will not be divisible by the same prime number. 3 and 5 do not have any prime factors in common, so you will stop here. The GCF is the product of the prime factors on the outside of the ladder. So we'll take the 2's on the outside of the ladder, multiply them together. 2 times 2 equals 4. And again, the GCF of 12 and 20 is 4. So you can see that it doesn't matter which method we used. We could use listing, prime factorization, or the ladder method, and all three methods will result in the GCF of 4. Let's look at some examples together. In guided practice number 1, we're going to find the GCF of 12 and 18 by listing factors. Again, I am not going to show you how to list the factors. We learned that in 4.1, so I'll just show you what the factors of 12 and 18 are. The factors of 12 are 1, 2, 3, 4, 6, and 12. The factors of 18 are 1, 2, 3, 6, 9, and 18. The common factors of 12 and 18 are 1, 2, 3, and 6. So they have 4 actual factors in common. But the greatest common factor of the two is 6. So the GCF of 12 and 18 is 6. In guided practice number 2, we'll find the GCF of 12 and 18 by using prime factorization. You can use factor trees to find the prime factorization of 12 and 18. I'm just going to show you what they actually are. So the prime factorization of 12 is 2 times 2 times 3. And the prime factorization of 18 is 2 times 3 times 3. 12 and 18 have 2 prime factors in common. They have 2 and they have 3. So I take these 2 prime factors and I multiply them together and I get 6. So the GCF of 12 and 18 using prime factorization is also 6. In guided practice number 3, we'll find the GCF of 12 and 18 by using the ladder method. Let's start by listing our prime numbers 2, 3, 5, 7, and 11. And then we can start our ladder. So we have 12 and we have 18. We ask ourselves which number in the prime numbers are both of these numbers divisible by. If I look at my list, 12 is divisible by 2 and 18 is also divisible by 2. So I'll put 2 on the outside of the ladder. 12 divided by 2 is 6, and 18 divided by 2 is 9. Again, I'll repeat the process and look at the top. Is 6 divisible by 2? Yes, it is. Is 9 divisible by 2? No, it isn't. So I have to go on to the next prime number. Is 6 divisible by 3? Yes. Is 9 divisible by 3? Yes, it is. So I'll put the 3 on the outside of the ladder. 6 divided by 3 is 2, and 9 divided by 3 is 3. Both of these numbers are now prime, so we can stop. We'll take the 2 numbers on the outside of the ladder, multiply them together, and we get the GCF of 12 and 18 is 6. Now it's time for you to do some work on your own. There are 3 problems: self-check number 1, self-check number 2, and self-check number 3. In these 3 problems, you will find the GCF of 2 different numbers by using either the listing, prime factorization, or ladder method. Go ahead and work these problems now and make sure that you put your answers on your paper and your work on the back side of your paper. Also, make sure that you put your answers on the notes that you will submit online to me.